Ryan with Miss.Geek here, and you're probably wondering what in the messy workbench is going on here. Well, that's a pretty good question, and I will explain here. So, what we're doing is part 3 of the Experience by Experiments variable capacitor series. And I think I might do a series on Experience by Experiments. I think that's a kind of a cool topic. So, let me know what you think in the comments below. About that topic. Basically, doing things that others have done, not because we're trying to, just because we're trying to learn, not because we're trying to advance the art necessarily. Although you never know, you can, but really the goal is to just learn by doing instead of saying, well, somebody else has already done it, so why should I do it? Well, it's for experience. Talking, for example. Anyway, so what I've got going on here is an experiment with the continued experiment with PCB-based capacitor, variable capacitor, and I've got 4 PCBs here, and what I've done is I've notched the edges or the corners so that I can stack them while they've got things soldered to them. I've got these DuPont leads here. And these 3 are uncut. These are just 3 plates. And this top one is cut just as I showed in the last video. And if you haven't watched it, I would recommend giving it a watch. It's only a couple minutes long. And that's the whole goal of these, is to be short. So I'm going to also try to keep this one short. So by connecting these together and in different combinations, I'm hoping to go from somewhere between 40 picofarad and 400 picofarad. Picofarad, not microfarad. So that's what I'm working toward. I have had it all connected. I had it up to around 400, but I'm trying to find the combinations that will get me from 40 to 400 in the smallest increments possible. And then once I have figured that out, I'm going to use these little switches here to make it happen. So that's the goal. I'm not going to video the whole experiment because I don't know how long it's going to take, and we don't have all day. So I've assigned all these values. So this is we have the A, B, C, and D boards. Just, A, B, C, D. And then we have from left to right, 1, 2, 3, 4. And of course the 4th one is about twice the size of the others. That's fine. It's just going to give me some variance. I'm just giving them arbitrary labels so that I can say, okay, A, B, which means these are the capacitor. If I say up here A, B, just AB. That's going to give me. Well, actually, I have to say A1B, and then I write down the capacitance. A2B, A3B, A4B, and then I start stacking them. A1, 2B, A13B, and it's going to take me forever, but I'm hoping to record all the different capacitances, find the unique combinations, and then develop a procedure for switching them incrementally from the lowest to highest. So I'll record my results and come back and let you know what I find. So I spent the last, 15-20 minutes or so going through a bunch of combinations to try to work from lowest capacitance to highest. And I started with this notation, A1B, A2B, knowing that A is the top layer, B is the second, C, D. So A1 and B connected, and then A2 and B connected, and so on. So I started, basically my lowest capacitance is about 40 picofarads, and then 46, and I get all the way up to about 90, and then if I connect everything, I get to 129. And I do pretty fair steps to that. So that's pretty great. And then, of course, I've got to worry about the other 2 plates underneath. And so I wrote those down here. And got anywhere from 137 picofarad all the way up to 406. There's a really big gap between 228 and 288. So it's about 60 picofarad. That's a pretty big gap, and I am concerned about that. And so I've actually thought about adding one more step by splitting either the C or the D plate. but I kind of don't want to do that just because I don't really think it's going to be that valuable. I'm curious about what your thoughts are. So if you want to leave a comment below, I'd certainly be interested in hearing it. But from 288 on up to 406, and these plates move around just slightly, so those aren't exact. They're not going to be repeatable until I, glue these together or whatever, or bolt them together by drilling a hole in the middle and then bolting it. Whatever I decide to do, that's probably the route I would go, and just use a nylon bolt to hold it. Assuming that I have one somewhere. Anyway, that's not the point. The point is that there's a big gap between 228 and 288. But don't forget, I have this 40 picofarad air variable trimmer. And that 40 picofarads takes me to 268, which is only a 20 picofarad gap between these two. And some of the steps are already going to be 20 picofarads. And I can't imagine that 20 picofarads is going to be the difference between an acceptable tune and something that's just too far out. So, I mean, and that's what the experiment's about, right? Do we really need continuously variable? And this gets a lot of continuous variance between. So what I'm going to do is I'm going to throw these in a spreadsheet, sort them, and then look for the 40 picofarad gaps that can be filled by this, and then see how many combinations there are and how they need to be switched in the simplest way using the fewest switches. And yeah, it's a lot of work to figure out, but once you figure it out, maybe I can get it down to 3 or 4 switches plus this guy, and then I can write down the combinations to get from lowest to highest and write them on whatever container I put this in. So anyway, that's the goal. I'll report back my findings in the next video. Thanks for watching. If you haven't subscribed, please do. And if you like the video, please click like. And if you have any suggestions, put them in the comments below. Thank you for watching. We'll see you next time.